We now move into building this video synchronization core, including the enhanced synchronization circuit. But first we start with the line buffer, which is just a dual clock FIFO because it takes a couple of clocks as we've seen, which is 100 megahertz and a 25 megahertz. We are not going to write code for this particular core. What we will do is we'll use the IP catalog to create an instance of it or instantiate it. The two more important specification about this particular FIFO buffer is actually its depth, and the depth should actually accommodate one row or one horizontal line of the VGA resolution, which tells me that you need about 640 values. Okay, and that's why we call it a line buffer. It's a FIFO buffer, but it's a line buffer because it can accommodate up to basically 640. We're going to do a little bit more than 640, but 640. This is basically how many pixels are in a line, and that's why we call it a line buffer. The next more important thing is actually the width. Okay, so each one of these rows, each one of these values that are 640 values should be 12-bit. And the reason why we needed 12 bits is because we have 4-bit per 3 colors for the red, green, and the blue. So these are the two most important values that we have. And of course, we do have a few. Basically, this is the data in, this is the data out. Both of them should be exactly 12-bit for the RGB, but we're going to add something we call the start bit, and this start bit will be basically telling me that your X and Y is 0 and 0, basically the very first pixel in a frame. So technically it will be a 13-bit, not a 12-bit. Okay, so the extra bit is actually just to know the start, and that will help us actually to synchronize between the two frame counters that we have in the system, the one that is global here and the other one here, which is the frame counter. Okay, so this is this is the most important specification for the FIFO buffer. Let's see how it's actually implemented. So I'm going to go to Vivado to show you that. In Vivado, there's a couple of ways to actually get that line buffer or build that FIFO buffer. So the easier of the two is actually the IP catalog. So I'm going to start with that one. You can actually go in here and just basically look for the word FIFO, and you'll see a bunch of them. The one we need is actually the FIFO generator here. You click on it and you'll get the wizard basically. So here the wizard has a bunch of settings. For example, if you actually type you have to have like a certain name for it because the code expected, dual clock macro, for example. And then it basically, what we need is we need to specify which FIFO implementation we want. There's actually a few of them. What we really need is something with a couple of clocks basically. So we're gonna select the one that says independent clocks, and we can basically use distributed RAM or block RAM. We're just gonna pick up the block RAM one. Specifically, what we're really having is this one here. That's basically the one what was selected. You can read the details about it, and you can read the documentation here. But anyway, you can go through the rest of the settings. For example, the settings we're using, I'm just going to go through this one here so I explain what we're actually using for our specification. So the first one, we're going to first word fall through because this is the one we've been using throughout the course. Basically the right width, we decided that we need 13-bit. This is how we actually do that. The depth, we need at least 640 values because it's a line buffer. However, 512 is too little, so we're going to just basically have it as a 1024. And the read width, you can have it basically asymmetric, but we're just going to use it as symmetric. For example, you can write 13-bit and read them 3-bit at a time, but we don't need to do that. There's actually, that's enough for our purposes. The next, you can actually see the status flags. These are actually important. So in the status flags, we're going to do the almost full. It's actually not the full signal. And this is actually important because this is the one that will tell me the stream int or stream input ready here. So we're just going to map the almost full flag. It's similar to the full flag, but instead of using that when the FIFO is full, we're going to just assume that it's almost full. And the almost full is usually asserted with certain a threshold. We can define that threshold. We're going to do that next. But basically, I'm going to take that signal and connect it in here. And as long as it's not almost full, basically, I'm going to say that the FIFO is ready and it can accept new data. And that's how we're going to do that here. So you go in here and you can see that basically it's programmable. We're going to say single programmable full threshold. Okay, that's what we're going to do. And we're going to assume that it's basically at the 128 and this one here will be 128 by itself. This is basically the threshold that we have, or 127. This is basically the threshold for the almost full. The same goes in here for the almost empty. You can actually check the almost empty if you want to. We don't, frankly speaking, we're not going to use it, so I'm just going to not use it. But you can actually, the almost empty is basically in here. You can just say basically if the stream output is valid. The stream output is valid, we're just going to say whether it's empty or not. If it is not empty, that means it's valid. There's actually something on the output, so the next system can actually read from it. You can also use an almost empty basically if it dips below a certain threshold, and that's basically it's the threshold you can set. You can see the data count if you want, and it specifies certain things. For example, the rate, you can figure out, the signal tells you how many data you wrote, or how many data has been written into the FIFO and how many data has been read from the FIFO. And you can see the summary. You click OK, it will just create that for you. So this is one way to actually do this. A different way to actually create this dual clock FIFO or the line buffer is actually using a template, and we're going to use that because it's a little bit different than what we've seen before. You can actually go to Tools, Language Template, and within in here you can actually go to Verilog, and inside Verilog there's actually a bunch of options. The one we do care about is actually the device macro, I believe that one in here, and then we are using an Arctic 7 device, and we are using something, I'm using BRAM, so I'm gonna click BRAM in here, and I did get this one here, which is a dual clock FIFO. And if you take a look at the code in here, it's pretty much what it does is like it generate, like the wizard generate this particular code eventually, but you can just basically copy that code and paste it in your signal without, and then you can change, or instead of going through the wizard, you can actually go through the parameters and the signals and inputs and outputs and do that. And that's basically what we're going to do. So we're going to take that, and then we can take a look at the code itself to see, or let's see how the code is implemented. So getting out here, the first thing you see is actually that. So the code I'm distributing actually does copy that code, and what it does, it just basically the names of these signals are a little bit unfamiliar to us. So what we're going to be doing is we're going to just create an instance of it, and we're going to create an input and output, and this code just basically renames the signals in a little bit more friendly way. So this particular code, which is BRAM FIFO FPRO, does nothing but create an instance of that dual clock FIFO that is set up correctly, and just basically renames these signals. And of course, set up correctly meaning like I've changed some of these signals in here, and you can read it on your own. It's pretty straightforward. Then we take that particular FIFO, and now we actually create that line buffer, which is the one that we have in here. So what do I mean that we create that line buffer? Of course, we take a look at it. Pretty much I'm actually creating an instance of that wrapped signal, and then all we're doing is basically we're creating these SI ready and valid and so forth. So let's take a look at it. When would it be ready? The SI ready, when would it be ready to accept new data? Well, it will be ready when it's not almost full. So basically when it's not full, but we're using the almost full. When would it be basically the SO is valid? When it's not empty, and that's basically what this tells me. So I created two of the handshake signals for the valid. Okay, the SI ready and the ready. Basically, we did the what we did is we did the ready in here and we did the valid in here. Basically the outputs, that's what we did. As for the input, we can actually just see the SI valid, and you can actually see where the SI valid is actually connected in here. It's generally speaking from the previous signal, okay, or from the previous core, and the SI valid, generally speaking, will be routed to the write enable at some point. So if you actually take a look at it, where is the SI enable or the SI valid? So here's the SI valid. You can go in here and it's probably connected in here, and that's the SI valid. It's connected to the write enable of the FIFO, which is actually connected to the write enable. It's just basically a write signal. So the SI valid is basically whenever you want to write a new signal, you just tell it, oh, well, the data that you have in here is valid, right? That's basically just the write of the FIFO. That's about it. The same goes with the SO ready in here. Okay, so the SO ready tells me, and you can see it actually here. So where is the SO ready? Here, okay, it's connected with FIFO read acknowledge. It's basically the read signal that will move the pointer forward. And that's basically how you create the line buffer. There's nothing to it but that. It's basically then whenever you need it in our full system in here, it's just going to create an instance of that line buffer, and you have all the handshaking signals. These ones here, as the serial in, serial out, and the serial in, serial out in here, the ready and the valid.